this is a piecewise function. F of x equal to this, this, and this within these respective intervals. So I want to find the limit of f of x as x approaches 2, as x approaches 4, and as x approaches 3. So let's dive right in. Now, to get the limit of f of x as x approaches 2, a condition hold. The left-hand limit, that is the limit of f of x as x approaches 2 from the left, must be equal to the limit of f of x as x approaches 2 from the right. Now, the limit of f of x as x approaches 2 from the left must be equal to this as x approaches 2 from the right. And if the two of them are not equal, then the limit does not exist. Now, this is our number line. I'm working with 2, so let me place 2 at the middle. To the left, I have numbers less than 2. 1, 0, and like that. To the right, I have numbers greater than 2, including 3, 4, and 5. So, to the left, I have x less than 2, and to the right, I have x greater than 2. So, this is from the left, and this is from the right. X is approaching 2 from the left, x less than 2, and x is approaching 2 from the right, x greater than 2. So, to get the limit of f of x as x approaches 2 from the left, I will look for where this interval lies, x less than 2. I can see that here x less than 2. So I'm going to make use of this function, 5x plus 3. So in this case, I will say 5 times 2 plus 3. 5 times 2 is 10. 10 plus 3 is 13. Okay, now let's check that of the right. X greater than 2. So in this interval, I have x greater than 2. This is 2 less than x. And 2 less than x is x greater than 2. So I'll make use of this function. So I have 2, or in brackets, 2 squared plus 5. 2 squared is 4. 2 times 4 is 8. And 8 plus 5 is 13. So you can see that the two limits are equal. That is, the left-hand limit and the right-hand limit are equal. So that is to say that the limit of f of x as x approaches 2 from either side exists, and it is 13. Because both left-hand limit and right-hand limit are equal. Now, let's look for the limit of f of x as x approaches 4. So the same thing we are going to do, the limit of f of x as x approaches 4. So let's look for both left and right hand limits. So for the left hand limit, that's the limit of f of x as x approaches 4 from the left. So going by that same analysis, to the left we have numbers less than 4, and to the right we have numbers greater than 4. So where is x less than 4 here? I'm coming from the left now. I have this interval, x less than 4. I can see it here. X less than 4. So I'm going to make use of this function to calculate for the left hand limit. So this is equal to 2 times 4 squared plus 5. 4 squared is 16. So we have 2 times 16 plus 5. 2 times 16 is 32. That is 32 plus 5. And this will give us 37. So the limit as x approaches 4 from the left is 37. What about from the right? So the limit of f of x as x approaches 4 from the right. So I have the interval s greater than 4. So where is s greater than 4 here? Oh, I can see it here. So I'll make use of this function now. So this is 4 to the power of 3 minus 5 times 4 plus what? 3. Let's see if the limit will be equal to this. If it is equal, then the limit exists. But if it's not equal, then it does not exist. 4 cubed is 64. 5 times 4 is 20. Then plus 3. 64 minus 20 is 44. 44 plus 3 is 47. So this is 47. Now, it's so obvious. Both left and right hand limits are not equal. It means that the limit of f of x as x approaches 4 from either side does not exist. That is to say, there is a discontinuity at the point x equal to 4. What about the limit of f of x as x approaches 3? Now in this case, I'm not going to approach x from either side, either left or right, because I can't see where x is less than 3 here, and I can't see where x is greater than 3 here. But I can see an interval in which 3 is a member of. The element within this interval is 3. So 3 lies within this interval. Now take note of this. The limit of a function as x approaches a certain value that lies within an interval exists. That is, the left hand limit must be equal to the right hand limit, and the limit exists. So in this case, the limit of f of x as x approaches 3 exists, and it is equal to 2 times 3 to the power of 2 plus 5. 3 raised to the power 2 is 9. 2 times 9 is 18 plus 5. And this will give me 23. In this case, the limit of f of x as x approaches 3 from the left is equal to the limit of the function as x approaches 3 from the right, and it is equal to 23. Thank you very much for watching this video. I hope you like it. Don't forget to subscribe, don't forget to like, don't forget to share this video to your classmates. I will see you in the next one.